NASA has recently announced that the James Webb Space Telescope has reached a point from which it could observe the universe for up to 20 years. It has traveled nearly 1 million miles since its launch on December 25th, and what a journey it's been. The telescope was launched from French Guiana in the form of a tightly wrapped package of wires, plastic, and gold-plated beryllium slabs. It had to unfold like a robot from the Transformers movies and shapeshift into, well, a telescope, with a golden 21-foot wide mirror gliding atop a silver sunshield as it traveled towards its destination. Following its launch on Christmas Day, the telescope spent the next few weeks deploying its mirrors, inspecting individual segments, and then maneuvering to L2, where it will spend the next 10 to 20 years unraveling the mysteries of the universe. James Webb will begin collecting light this summer, according to NASA Administrator Bill Nelson. To commemorate the occasion, the Virtual Telescope project captured images of James Webb in orbit to give people a sense of what it looks like in space. Unfortunately, other than a bright dot in the night sky, there isn't much to see there. But like Carl Sagan's famous pale blue dot image of Earth, taken by Voyager 1 on its way out of the solar system, or Cassini's The Day Earth Smiled image, that small point of light holds a tremendous amount of significance in human history. ELENA was used to capture the image of the JWST on January 24th. This robotic telescope automatically tracked the apparent motion of the JWST and acquired a single unfiltered exposure that shows the telescope's position, indicated by an arrow in the center. The JWST has arrived at its final destination, L2, when it was photographed, putting it at a distance of approximately 1.4 million kilometers, or 869,920 miles from Earth. In addition to the image, the VTP created a short GIF animation that depicts the apparent motion of the JWST against the stars. While it may appear to be nothing more than a tiny dot against the background of brighter dots and the darkness of space, these images tell the story of a decades-long mission. Work on the telescope began in 1996, and it was initially expected that the James Webb would be launched in 2007 with a $500 million budget. Unfortunately, due to a major redesign, issues with the sun shield, and the Ariane 5 rocket that would launch it, there were numerous delays and cost overruns. Delays were also imposed by the COVID-19 pandemic, as well as the fact that the James Webb is the most complex and advanced space telescope ever conceived. The telescope's origami-like nature, due to which it has to fold up to fit within a payload fairing, required extensive testing runs, time and again, and even minor issues necessitated retesting and safety checks. Construction was finally completed in 2016, but an extensive testing program was still remaining. The telescope testing was completed by late 2021, and the James Webb was shipped to Kourou, French Guiana, for integration with the Ariane 5 rocket. The launch, which finally took place on Christmas Day, went off without a hitch. "It's truly Christmas with all the presents and everything, and we have a space mission," said Thomas Zurbuchen, NASA's Associate Administrator for Science Missions. The mission team is now at L2 and waiting for the telescope to reach operation temperature. The telescope's instruments will then be activated, followed by final testing and calibration. If all goes well, NASA expects the James Webb Space Telescope to begin collecting light in June 2022. James Webb, the name behind the project. You may be wondering, who has the honor of having such a historic telescope named after them? That honor belongs to James Edwin Webb, NASA's second administrator, best known for leading Apollo, the first space program to send humans to the moon. He was also a key figure in the 2 crewed space missions that followed Apollo, Mercury and Gemini. While Webb died in 1992 at the age of 85, he left a massive legacy worthy of a telescope named after him. It's fitting that Hubble's successor be named in honor of James Webb. Thanks to his efforts, we got our first glimpses at the dramatic landscape of outer space, said former NASA Administrator Sean O'Keefe about the observatory's name. He took our nation on its first voyages of exploration, turning our imagination into reality. However, the telescope hasn't always been known as the Webb Telescope. It was initially known as the Next Generation Space Telescope, James Webb Space Telescope. Size: the JWST, hailed as the Hubble Space Telescope's successor, is the largest space observatory ever built. Its massive sunshield base is 22 meters by 12 meters in size, roughly the same as a tennis court. Despite being nearly twice the size of Hubble, which is only 13 meters long, the JWST is nearly half the weight at 6,500 kilograms. The gold-plated mirrors on the JWST have a total diameter of 6.5 meters, which is much larger than Hubble's 2.4-meter plate. Overall, the JWST will have a 15-fold wider field of view than Hubble. The JWST Observatory will study objects over 13.6 billion light-years away with its infrared telescope. Because of the time it takes light to travel across the universe, the JWST will be looking at objects that existed 13.6 billion years ago, approximately 100 to 250 million years after the Big Bang. This is the most distant point in time ever observed by humanity. But where will the James Webb Space Telescope be positioned in space? The JWST will orbit the Sun after being launched into space, flying up to 1.5 million kilometers from Earth in temperatures as low as negative 223 degrees Celsius. In comparison, the Moon is 384,400 kilometers away, whereas the Hubble Space Telescope is only 570 kilometers above our planet. Since the JWST will be so far from Earth, It will be unable to be serviced by astronauts if any problems arise. What distinguishes the James Webb Space Telescope from Hubble? In many ways, the James Webb Space Telescope is seen as an improved successor to the Hubble Space Telescope, which was launched in 1990. But are they comparable, or are these two telescopes vastly different? To begin, both telescopes observe light in different ways. The Hubble Space Telescope's primary focus is on visible and ultraviolet light. While it can observe a very small portion of the infrared spectrum, it's nowhere near as sensitive as the JWST. The James Webb Space Telescope is intended to study the infrared spectrum. It will not be able to see in ultraviolet light like Hubble, but it will be able to focus on bright objects such as very distant galaxies. The James Webb Space Telescope is also significantly larger than the Hubble Space Telescope, owing to its large sun shield. This is used on all space telescopes, but it is especially important on the James Webb because of infrared cameras. If it's not kept cool, it may become blind to the lights of the objects that it's attempting to observe. Another significant difference between the two satellites is the distance at which they'll be kept. The Hubble Space Telescope orbited above Earth's atmosphere, but it was close enough to be approached if repairs are required. The JWST, on the other hand, will be 1.5 million kilometers away. That is both further than any human has ever traveled and too far for anyone to ever reach to repair the satellite if something goes wrong. It needs to be in an area where the gravity of the Sun and the Earth work together to keep the satellite in place, and far away from the Earth's reflected radiation, which will keep it cool. First target for JWST. The JWST has entered its final destination in space, and the mission team is preparing the next generation space telescope for observations. The James Webb Space Telescope is aiming its first observations at the Big Dipper. Although the spacecraft is still months away from starting its official scientific observations, one particularly bright star, known as HD 84406, will be the focus of JWST's attention soon. A bright point, such as HD 84406, provides a useful target for the team to align JWST's honeycomb-shaped mirrors and begin gathering the engineering data. This star will be important for this purpose, but it will not be studied by the observatory once it begins its projects. HD 84406 will be too bright to study with Webb once the telescope starts to come into focus. But for now, it's the perfect target to begin our search for photons, a search that will lead us to the distant universe. According to a NASA blog post published on January 27th, written by Jonathan Gardner, Webb Deputy Senior Project Scientist from NASA's Goddard Space Flight Center, and Alexandra Lockwood, Project Scientist for Web Science Communications at Space Telescope Science Institute.